Hello everyone. So today we're going to go over section 10.1, modeling and solving one-step equation. So once again, the definition of an equation is a mathematical statement that equates two expressions. Okay, so let's look at some examples of this. We can have something as simple as 1 plus 1 equals 2. That is an equation. The expressions are 1 plus 1 and 2 respectively. And of course, we can also have equations that have a variable. So something like 2x is equal to 4, or something like x equals to 1 plus 1, or something even with two variables. So we can have x plus y equals 5. So if you look at the middle two equations here, we can solve for x, and that is to find out the value of x for which this expression is true. So we have x equals 2 in both cases. However, for the equation on the right, we can have multiple values of x and y. So for example, we can have 3 plus 2 equals 5. We can have 4 plus 1 equals 5. And we could even have something like 2.5 plus 2.5 equals 5. So what is the difference between the middle two equation and the last one is that for these two here, the solution is unique. And that is to say, we can have one solution and that's it. So in both cases, the solution just happens to be 2. Whereas in the last equation here, because we're dealing with two different variables, in this case, we have multiple solutions. And the solutions are not unique. Okay, so specifically, we talked about before linear equations. So those are equations, of course, that form a straight line. With a most likely an x variable and a y variable. So something like what we had before as example, something like s is equal to 4f plus 1. Just like in our last bit of notes before today, p is equal to 8f plus 4. Or something like even y equals 7. Those are all linear equations because when you've graphed them, they form straight lines. So the equations that we're going to be working with will only have one variable and will have one solution. So, and that's important to note. So linear equations we are working with will have one variable and again one solution. Okay, so the process of finding the solution is called solving the equation. Going to be hearing that phrase a lot in this chapter because that's what the chapter is about. So we're going to talk about three different ways that are quite similar of solving equations. First one is to look at the equation and try to figure it out intuitively. So in this first case, you can see that we're looking for a number. If we add 4 to it, we have 8. So it makes sense that the x variable is going to be 4 here. We're looking for a number that we subtract 2 will give us negative 12. So that, of course, is negative 10. Since negative 10 minus 2 is equal to negative 12, of course. Next one, we're looking for a number that if I multiply by negative 4 will give me positive 12, so the number itself must be negative. So I have negative 3. And finally, a number that's when it's divided by negative 5 gives me plus 4, so that will be negative 20. Now, you're most likely going to want a more systematic way of solving these equations rather than by inspection, and that's what we'll be looking at. But before then, it's a couple of examples where we try to solve equations using models and diagrams. We're going to talk about why it doesn't always work that well. Okay, so we have 3c equals to negative 9, so we can treat the 3 c's as boxes. Each one is c. So we have 3c. And negative 9 can be placed inside of these boxes. So let's go and do that. So negative 1, negative 2, negative 3, 4, 5, 6, 7, 8, 9. So each of these containers, the C's, will contain negative 3. And that is to say that for this equation, C is equal to negative 3. Okay, so the equation on the right, you are trying to divide w by negative 4 and have it equal to 3. So because of this negative value here, the negative 4, the negative sign makes it very hard to draw a diagram. So it's not always the best to try to use models and diagrams to solve equations either. So negative signs make diagram hard to draw. You could still do it, but it's not too efficient. So if you were to look at this question by inspection, however, you can most likely see that a number divided by negative 4 gives positive 3. That's going to be a negative number, and negative 12 will work there. So a more systematic way of solving these equations is to use what's called isolating the variable by using inverse operation. So that's some new terms for you here. First one is isolating. It just means that if I have an equation with a variable, let's say the variable is x, I want it to say x equals to then a number. And that's called isolating the variable. It gets a variable by itself, and then on one side of the equal sign. And again, we can do this by applying the inverse opposite operations. The inverse operation is the preferred term. So that's good to know, of course. And we'll be addressing the operation as inverse operation throughout this chapter. So basically, the inverse of addition is going to be subtraction. Of subtraction, of course, then is addition. The inverse operation of multiplication is division. And finally, the inverse operation of division is multiplication. Okay, let's try this out using inverse operations to isolate the variable. In the first example, we have x plus 3 equals negative 11. We're going to subtract 3 from both sides. Of course, you can see here the plus 3 and the minus 3 will eliminate each other. And so we just have x equals to negative 14. The inverse of minus 7 is plus 7. Then, of course, the 7s are eliminated. So we have x equals to 22. And then the next inverse operation to look at is the inverse of multiplication, because this actually reads as 17 times x. So we're going to divide both sides by 17, which eliminates the 17s. So we are left with x equals to negative 51 divided by 17, which is negative 3. Next one is similar. We're just going to go ahead and divide here. Okay, so we're going to divide by negative 3 on both sides. The negative 3's will eliminate each other. We're left with x equals 5. Likewise, for the next one, the inverse operation of dividing by negative 4 is to multiply by negative 4, of course, on both sides. So the negative 4's are eliminated. We're going to be left with x equals to negative 28. And finally, the last one, there's a negative sign, and then it's going to be divided by 6. So to take care of both those at the same time, we can just simply multiply both sides by negative 6. And we'll be left with x equals to positive 18. Okay, so the next kind of question is I'm going to give you a specific solution, and you can see if it works. Obviously, you can just go ahead and solve the equations. You can add 4 to both sides. For example, 4a, x equals negative 3, so that works. Negative 3 is, in fact, the solution. Second one, we can divide both sides by 4. Fortunately, here x is equal to 3, so that's not a solution. As in, x equals negative 3 is not a solution. And finally, the last one, you're going to multiply both sides by negative 3. So, of course, 1 times negative 3 is going to be negative 3. So that's a solution there. The other way that you can solve this question is to use what's called substitution. So what we can do is simply substitute in negative 3 into the equation. So negative 3 minus 4 is supposed to be equal to negative 7, and negative 7 does equal to negative 7, so that works. Here, 4 times negative 3, we want it to be equal to 12, but negative 12 is not 12, so that doesn't work. And finally, we have negative 3 divided by negative 3, and of course, that makes 1 equals 1, so that works. So it's good that we can either solve the equation itself to check if x is equal to negative 3 as a solution, or we can use negative 3 as the solution and substitute it back into the equation to check if it works. So in both ways, you should get the same answer, and that is it works here, it doesn't work here, and for example C, it works. So that's good to know. Okay, next piece. We're going to talk about a simple word problem here. Oscar can bake 23 cookies in an hour. He wants to bake 276 cookies for his party. We're going to write an equation. So that will be 23 times the number of hours he bakes cookies for. And we want a total number of cookies to be 276. So this is the variables involved, of course. The numbers involved, of course. The 23 is cookies per hour. And then H, of course, is the number of hours. And the 276 is the total number of cookies. And we're going to be asked how long does that take to make. Quite simply, we can just go 23H is equal to 276. And we can divide both sides by 23 because we want to isolate the variable H to find the number of hours that Oscar is going to need, and we will get 12 hours. Make sure to include units. And that's it. So very simple introduction, which is one-step equations. In the future, we're going to look at equations involving more steps, but all of them will be linear and only have one variable. Thank you for listening today.